Hello viewers and welcome. It's about time for a teardown, and today we're going to be having a look at this beast. But first I want to let you know that this is a bit of a special episode, as it is the first one to include a channel sponsor. So I want to take a moment to thank and welcome PCBWay, who will be here for at least the few coming months. I'm sure you can guess that they make one-off and short-run PCBs for hobbyists and professionals alike. So if you're in the market for having some PCBs made, then go check out their website. There'll be a thing popping up there, and there's links to their website in the video description. I also have some future videos where I'll be making some PCBs myself, hopefully to repair a particular issue on one of my Quantel devices. So I'll be using PCBWay for that, of course, so keep an eye out for those. You'll actually see their PCBs firsthand. This is also a good time to mention my loyal patrons, most of which have been putting money into the pot for a very, very long time. If you want to help out with extra funds that allow me to buy more interesting things to take apart, then head over to Patreon and throw some coins into the hat. There's links up there on a card and links in the video description. Okay, some of you will remember the Sony DVW-500 Betacam VCR I took apart a while ago. It was really interesting, and that it dated back to the early 80s, the design for that one. So for this one we need to wind forward a little bit to 1993, where they introduced this system that we're going to look at today. A little bit of history. In the 90s, the world of TV broadcasting was rapidly going digital. You know all this from all the Quantel stuff that I look at. And it was a time for Sony to refresh the Betacam system and move from analog into the land of digital. Sony introduced the digital Betacam system in 1993. It quickly gained the name DigiBeta by those that used it, and it began to replace the Betacam SP format that had been in widespread use. Now, the really interesting thing I found with that old Betacam deck was the dynamic tracking and the whole head assembly. The dynamic tracking was really interesting to me. It basically used electronics to steer the video heads vertically as it actually scanned the videotape, and that allowed them to correct for tracking errors, making for an extremely good picture. Dynamic tracking wasn't a particularly unique thing. In fact, there was even some domestic VCRs that used it, but it was an important addition to Betacam, and the DigiBeta system also uses dynamic tracking. So I'm going to be really interested in seeing how they've re-engineered the video heads, the drum, and possibly the tape threading assembly, see how it's changed. So let's take a look at some specifics of the DigiBeta system. This is a DVW-500P. You would have been able to read it off here, but the front panel's missing. I think this machine's had a bit of a hard life. There's actually a few versions of it. There is also an A500P, and it could also have different front panels. This pull-out panel here, you could have a different one. One that actually had a screen on the front for doing more sophisticated editing. And there were different versions for the different regions. So you had 625 and 52 line versions. Additionally, there was also a PAL or NTSC decoder to allow them to record composite video, because typically they didn't have any option to record composite video because it wasn't really needed in the broadcast world, so it was just an optional extra. And that would be a plug-in card which plugs in the back somewhere. The other variant of this machine was the A version, and this allows you to play back the old Betacam SP tapes, so it allows you to play back the old analog format. So a bit of backwards compatibility there, but as I said, not all the machines actually had that. From what I've seen, most versions of the 500 are the A500 without the composite video board. It seems that most places specified the analog backwards compatibility option for obvious reasons, really. Now, as I mentioned, that the DigiBeta system can play back the old Betacam SP tapes. You can probably guess that the tapes are physically the same. I've just got two here. That is a Betacam SP small, and we've got a DigiBeta small here as well. So yeah, obviously the case is exactly the same, but the tape is different. There's a different tape formulation on the digital tapes, and of course it's also we also have the large and small tapes. So one of the big ones there. Yeah, quite big cassettes for these. If I compare that to a VHS, yeah, you can see there a big difference in size. Now, the tapes could hold either 40 minutes for the small or 124 minutes for the large at full resolution, which is 576 lines, unlike the old Betacam format, which was only 340. Being digital as well, we also have a defined vertical resolution, and that is 720 pixels. So that gives us a total picture of 720 by 576 for the 625 line regions, and 720 by 486 for the 525 line regions. Now, in terms of the video itself and how it's actually recorded on the tape, the video is digitized at 10 bits and encoded with DCT, or discrete cosine transform. This is essentially the same method which is used in JPEG and MJPEG compression, but it isn't either one of those. It's just using the same mathematical method of compression. And if you want to know more about DCT, then I would highly recommend several computer file videos on the subject. I will drop a link to them in the description, and I'll see if I can put a card up there to link to some of them. There's a lot of really good information there about how DCT compression works. Now, the actual video bitrate is about 90 megabits per second for the video, and there is also 4 channels of audio. Again, all digital at 48 kilohertz, 20 bits each, and that is all uncompressed PCM. Now, with all this being digital, we need some digital inputs and outputs because there isn't much point in having digital recording if you can't get the data in and out as digital information. Actually, I think what I'll do, I'm just going to turn this round so we can look at the back and show you some of the ports, because that might help a little bit. Right, that's a bit better. We can see the rear panel. So the digital video is all via SDI, which is serial digital interface. For the time, that was a bit of a relatively new format. But it was starting to appear on a lot of broadcast equipment, mixers, graphics equipment like the Quantel Paint Box. So SDI is a digital uncompressed video interconnect used throughout the broadcast world, and it is still in use today. Though the bitrate obviously today is a lot higher than it was back in the day. It normally takes on the form of a single coax 75 ohm with BNC connectors. SDI data is essentially a serialized version of the older BT656 and Rec 601 standards from the 1980s. The parallel version encodes YUV video at 10-bit 27 megahertz with 422 encoding, with the serialized SDI version being 10-bit at 270 megahertz because it's just been serialized. Now, SDI can also carry embedded audio, which these machines do use. So you've just got a single interconnect which carries all the video and audio together. So with that all said, the overall compression rate is about 2.3 to 1 off the SDI, which, if you do some maths and account for some protocol framing overheads, we're pretty close to that 90 megabits per second bit rate. Here at the back, this is going to share a lot of the same ports that we saw on the old BVW. We've got XLR connectors for all the audio, we've got component in and out, we've got composite listed here, but if there is no internal decoder board, these ports here just don't do anything. They're they're installed whether you have the optional card or not. So we've got component outputs, we've got the digital inputs and outputs. Those are always marked in blue. So we have 4 SDI outputs, SDI inputs, and we've got the 2 digital audio connections as well. Now, after I made and released that BVW-75 video, it seems I might have upset some of you by destroying it, but the way I see it, I take apart one of these things and allow thousands of people to see what's inside without them having to take one of them apart. And like the BVW before, this machine is at the end of its life. It doesn't work, it's got errors, it's not worth fixing. These are 10 to a penny here in the UK. I've got another one in here that has really low drum hours. It's in really good condition, and it was literally given to me because they had no use for it. I think a lot of people will thank you for taking them away, to be honest. So I have no issue about scrapping this machine. If I hadn't have picked it up for you to see a teardown on, it would have been in the scrap bin already. So no flames here, please. Why is this so heavy? What have they put in it? Lead. They made the power supply out of lead. Okay, let's take the lid off. I've actually already loosened the screws. There's actually 3 here. Obviously, it's really designed to be removed. Just having 3 large screws like that. So if we take the top cover off, what we have is looks like the power supply over at that side there. There is a large backplane right down at the base that was similar to the BVW, but now we have 1, 2, 3, 4, 5 large cards plugged in here. I seem to remember on the BVW these were much smaller and you had more cards, and there's 2 cards just here, but we've also got some missing slots, missing cards here, and I would expect those are for the analog Betacam SP playback cards and that composite decoder board, which I think goes in there down on the last slot. To access the tape transport, we've got the metal cover here with these 2 clips, and this allows us to go in and actually take off that cover and gives us access to the tape transport and drum assembly. Yeah, nice little retention bracket with rubber mat thing to press down, hold the card in place, and a captive screw. Nice attention to detail. So we've just got another one here. Right, I think what I'll do is take out these cards. I'm just going to start making everything a little bit lighter, so when I start moving it around, it won't be so bad. And we'll have a look at those a little bit later. Okay, I've just removed the screws to take off the front panel. So there's a sliding rail and a little scissor arrangement on this bit here. So we just need to take the connectors off. And that allows us to remove the whole of the front panel. Right, so it's definitely starting to get a bit lighter now. So the top of the tape transport, I seem to remember this comes out like the old BVW. I seem to remember it's just just the thing that comes out. There we go. That is where the cassettes actually go in. There's some belt drive arrangements in there to draw the tape in, and we've got a mirror there. Not sure what that is all about. Oh, there is actually, yeah. There is actually a motor in here, just in there. So, well, never mind. There's a couple of optical sensors on here, obviously for detecting when you're pushing in a cassette. Oh, I see. Yeah, because we've got two different types of cassette, the large and small. It's going to need to know what size tape you're actually putting in. So there's actually a small plastic thing here. So on the smaller cassette it would push in. Would that be the larger one? Where's the tapes? Yeah, if we look at this, if you insert a small cassette, it pushes these two sensors. They're just little optical sensor there. So both of those, but these ones aren't activated. Well, it's just that one actually. But if we put in a large cassette, it activates all of them. So you push in that one, that lifts up this one here, and then it operates the two side ones, and that would activate the tape load process, and will adjust the actual spacing of the spools, because of course they are further apart on the large cassettes. So we're starting to see lots of engineering goodness in here. From memory, this is quite similar to the Betacam SP machine. We've got the two spools, and there's a mechanical system which allows the machine to adjust the spool size. So just on the gears and cams and what have you. Looks like we've got a load of plastic like pogo pins. These will be obviously picking up information from the cassette, probably whether it's a large or small. What else would you have? Whether it's a digibeta or an older analog cassette. Yeah, I'm not quite sure why you need so many. I guess they have their reasons. There's take-up spools with a nice brake arrangement. It's actually got little brake pads. Oh, it's got little brake pads on it, so it can brake these. Yeah, we've got the looping assembly there, which is going to pull the tape out of the cassette and loop it right round. That was one of the things where the Beta logo actually comes from, because it wraps almost all the way around, right over to here. So it'll be from here all the way around to there. So it's nearly 360 degrees around the head, or drum, I should say. You know what? Maybe I should have read the service manual. It's probably got instructions in there how to do this. God grief, look at this. That's like 1 mil thick sheet steel. Actually, thinking about this, these look like video control wires. That's from the video heads. These are all spindly little wires. There's not going to be enough power in here to run the drum. and these motors here, so there must be some more connections underneath. So I've just realised, taking this base plate off, that this is prefabulated amulite. Now I've not seen that in a long time. So what we're looking at, so we've got the back plane that all those cards plugged into. This area along here. We can see the power supply and all the power connections coming out at the bottom there, running through, plugging in onto here. We've got a big ribbon connector connecting from the base, the back plane, onto the base of the tape transport, I think. Yep. Right, third time lucky. Whoa, there we go. Right, there's not much left in the chassis now. We've got the power supply, that back plane, but there's literally nothing on that apart from connectors. We've got the VU meters at the front. I might take that out off camera. There's not really much else to see in there. I'll probably save the power supply, keep that as a spare. Right, so what we'll do next is have a look at all the circuit boards. There's only a few, so I thought we'd quickly run through them. And then after that we'll have a look at the tape mechanism. Doesn't seem to be a huge amount of information in the service manual for all the boards. Couldn't even find a block diagram. It basically just talks about electrical alignment and adjustments and things like that. It doesn't actually really go into much detail about what the boards do and how they work. So a bit of a loss on that one, but we'll see what we can figure out. So there's a number of things on this board. We've got 1, 2, 3, 4 custom Sony chips. Who knows what they do. There's some other chips here as well with little heat sinks on. They are actually bonded on. So we've got 3, 3, 3 and 3. So it looks like we've got 4 separate channels of something. Relays at the top. There's a little bit of legend going on here with some test points. Let's just read what these say. CNF BD cell, CNF AC cell, cell normally means select, ADV BD, rec BD, that means record, AC cell, CNF, not entirely sure what those could be, to be honest. There is a lot of references to PLL on here. We've got ADV AC PLL / VIT. ADV BD PLL VIT, CNF PLL VIT. PLL is phase locked loop. I'm not sure what VIT might be, unless it's something to do with the VIT-C, which is the vertical interval time code, which is a time code that's written into the frames of the video, which aids in editing and stuff. Could be, I'm not entirely sure. Let's see if we can pop one of these heat sinks off. See if there's anything written underneath there. Now handily, this particular one has been installed a little bit wonky, and it means I can actually get my screwdriver underneath, so we'll see if it pops off. It's obviously been glued on with some kind of gooey something, so let's see if we can pop it off. I don't really care about any of this. Well, that's an easy way to decap it. I wanted to see the number. Where did that go? Oh, just retrieve the top of it. Let's see if we can get the cover off. See if it actually has a number on. And it's just another custom Sony part. So yeah, that's probably not going to really tell us anything. I'll do a quick search, but you don't normally find much when it comes to Sony chips. And no, the only thing I found was a Sony car sub amp, which has the same model number as CXA 1800. So yeah, not much information there. So this board looks like it's a bit more analog, as in terms of actually operating the video heads, the audio heads and all that sort of stuff. There's various bias levels and reference adjust, peak, Q peak signal, Q meter adjust, LTC crosstalk, Q erase adjust, so lots of stuff like that on here. Not so many custom Sony parts, can't really see any actually. A couple of relays, channel 2 head tune. Yeah, there's all sorts of analog tuning and kind of stuff going on there. Let's have a look for dates, see if we can start dating this. Possibly 1993. Can't really see much on about the other one. Oh, we've got 9501, and that other custom part was 1994. So yeah, around about 1994, 95. Looks like this machine was made. Let's have a look at some of the larger boards. So I think it's pretty obvious what this one is. Well, to me anyway, this is the digital control board, as in like the processor, CPU card, if you will. Looks like it's divided up into several sections. 1, 2, 3, 4. We have EPROMs in that section, one in this one, and one here. Lots and lots and lots of Sony custom. Sony. Fujitsu, Zilog, Sony, NEC, Sony, NEC, and another Sony. We've got a Hitachi part there, so that's possibly a CPU. You could well find a few small CPUs that each do different tasks. So yes, we have 2 EPROMs here, DVW Sys1 and Sys2. We've got a Zilog Z84015110. Our PDF shows that as a Z80 based microcontroller thing, CPU. We've got a Dallas real-time clock, that's probably flat by now. Fujitsu MB something, that's bound to be RAM, surely. No idea what the other Sony stuff is doing. At the top here we've got some buttons, diag adjust, adjust memory. So this has quite a sophisticated diagnostics and configuration menus, both ones that the user can change, and there's also engineering menus as well, where you can actually change some really quite granular bits of the machine. You know, literally motor torque levels and tape tensions and all sorts of stuff. So these buttons here might be to access some of those more engineering-y type stuff. We've got a section here called SAT. This block here. So we've got RF, AC, TIM, who knows, RF pilot. So there's obviously looks like some RF stuff going on here, because you have to remember that the tape the video is encoded onto the tape at 90 megabits per second, and that's 90 megahertz. So there's definitely some RF stuff going on here. So if we move you up to this top corner, we've got some more stuff going on here. Dip switch settings, another EPROM, more Sony parts, Fujitsu part there, Sony. Small logic elements there. Looks like it's got the name DT, whatever that means. Digital something. Right, can you guess what this one might be? I think this might be analog video. So yeah, we've got, there's definitely some symmetry going on here. 1, 2, 3, 4, 5 channels of something going on there. So yeah, this is going to supply all the component video input, output. There'll be the composite output. There'll be, this might even do audio as well. This might have the analog audio sections on. So yeah, there'll be a fair bit going on there. Relays, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 relays on there, with a bit of what looks like digital stuff going on here. This might be digital control over some of the analog inputs and outputs that's operated from the menus. Right, so the next board is this one. Definitely getting into some heavy lifting digital processing going on here. Yeah, we've got a number of really large integrated circuits, most of which are Sony. In fact, they are all Sony, apart from the RAM and some glue logic. So let's have a look. So we've got these. You don't see these very often. The ceramic surface mount jobs. You don't see that very often at all. It's normally the plastic packaging. So these two are Sony. I'll read out the numbers anyway. CXD8811 for that one. We've got CXD8824A. That one, CXD8806, CXD8807, CXD8928R, same as that one, and these ones up at the top here. I'll zoom in a moment so you can see them a bit closer. CXD8929R, and that's the same as that one. So definitely this bit here looks symmetrical, so I think there's some parallel processing going on here. If we zoom in a little bit onto this section, so we've got these two large ceramic ICs here, and these two here, and we've got a number of SRAM chips. These are 128K each. So I'm going to hazard a guess that these are doing the DCT processing. Now, given that there's two of them, I'm going to also hazard a guess that one is doing one field and the other one is doing the second field. So field 0, field 1. So if we add up the RAM, so that's 256, 512 on each, that would be enough to hold an entire field of picture data to do the processing on. On this side, don't really know. I mean, there's going to be a whole bunch of glue logic and processing and various things going on, so I think it's going to be hard to figure out exactly what's going on here, but there is lots of RAM. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And that gives us 2 megabytes of RAM over this area. I should also mention that these are static RAMs, not DRAMs. Unusual to see these types of surface mount in a non-square package. Can't say I've really seen that before. Okay, I've just realised that there is a shielding plate on the back, so I thought probably worth checking underneath, and there isn't a huge amount on there, it's just more memory. So yeah, there is a slight increase on memory from what I've just said. So I think I can tell what this card is for. It's for the SDI inputs and outputs, which is the digital video. Some what looks like glue logic there, a couple of custom chips. More there, but most importantly we have these SBX 1601 and SBX 1602, and I know these from my Quantel products. This was a chip that was developed by Sony to serialize video data into an SDI output stream. So we have two 1601s which are outputs, and a 1602 which is an input. So this one receives SDI, and these ones output it. Interestingly, these are the notorious Sony SDI chips, which were prone to failing, and indeed, these chips have killed a number of Quantel things that I've seen, and the repair to one of my Quantel things, which is the ramcorder. That is going to be to design something which can drop in place of one of these and actually work instead of just dying, which these certainly do. So yeah, interesting to see those in here. I wonder whether they're still working or whether they have died like all the others. But apart from that, there's not a lot going on. Interestingly, there is some over on this side here, there is some unpopulated parts. I'm not sure what they would have been used for. Right, so let's have a look at this final card. There's a bit more information on the legend, on the silkscreen on this one. We've got timing generator, this section, input block. We've got VCR, which is the time code stuff, which embeds a digital time code into the actual picture. So that will probably do the encoding and decoding of that. I've got a little bodge board here that should be mounted on. EVR, what would EVR be? Not sure. We've got TBC buffer, which is time-based corrector. You often need stuff like that when you're operating with tape, because being a mechanical format, there's always going to be some timing variations. We've got encoder, possibly. We've got DAC, digital to analog converter. Ref, that's going to be some sort of reference. Is there any detail on? Oh, that's all ref. ADC. So yeah, there's a fair bit going on that board, but again, it's all mostly Sony custom chips, so I can't really get any information on them. Right everyone, so you've already been through 37 minutes of footage, which is a huge amount. So what I'm going to do is split this up into 2 parts, and you'll see the rest of this mechanical beauty in part 2. So I'll see you there. Bye for now.